So we are going to start out by solving a non-standard linear programming problem, and this one is a minimization problem. So using the methods that we've learned in class, instead of minimizing this problem, we're actually going to turn it into a maximization problem. So we want to do the complete opposite. So instead of minimize, we want to maximize this thing, because we know how to maximize using the Simplex method. So to maximize, which is the opposite of minimizing, what we're going to do is change all of the signs from our objective function. So to turn this into a maximization problem instead of a minimization problem, we're going to do the complete opposite of what it tells us to do in our objective function. From here, this is the exact same process that we work through with any other maximization simplex method problem. So start by adding slack variables or surplus variables where needed. We have a less than or equal to sign, so that means this one is going to get a slack variable. We'll be adding S1 to this first inequality, and this second inequality is a greater than, so we'll be subtracting our surplus variable from there. So rewrite your linear inequalities as equations. We have 8y1 plus 7y2 plus 2y3 plus S1 is equal to 13. And our second inequality looks like 8y1 plus 14y2 plus 6y3 minus S2 is equal to 10. And our objective function, same as before, we'll take all of these variables, move them to the left side with our z. So this looks like 56y1 plus 56y2 plus 43y3 plus c equals 0. Okay, so these are the first two steps for solving a linear programming problem using the simplex method. Now turn this into a matrix. So we have three equations. So our matrix will have 3 rows, and we have 1, 2, 3, 4, 5, 6, 7 different types of variables. So this will be a 3 by 7 matrix, 1 column for each type of variable. So we'll have a column for y1, y2, y3, s1, s2, z, and then 1 for our constants. So go ahead and fill in your matrix. In my first equation, my coefficients are 8, 7, 2, 1, 0, 0, and 13. My second equation, 8, 14, 6, 0, negative 1, 0, and 10. And my third equation, 56, 56, 43, 0, 0, 1, and 0. Okay, so this is what my initial simplex matrix looks like. If you read the solutions currently from our matrix, y1 is equal to 0, y2 is equal to 0, y3 is equal to 0, s1 is equal to 13, s2 is equal to negative 10. Here's a problem. We have a basic variable that has a negative value for its solution. This can't happen. We need to fix it. So we're going to have to focus on turning this variable from a negative basic variable into a non-basic variable. So start by indicating the row which has the negative solution, or the negative solution. Go as far as you can to the left of this row, looking for a positive number. So 8 is the number that is furthest to the left that is positive. This is your pivot column. So all of your pivots will always happen above the indicator row. We need to decide which one of these numbers gives us the smallest quotient. 13 divided by 8 or 10 divided by 8. Okay, so do each one of these and see which one of them gives you the smallest quotient. So if we do 13 divided by 8, we get 1.625, and 10 divided by 8 is 1.25. So this second 8 actually gives us the smallest quotient. This becomes our pivot position. Now that we've found our pivot position, we need to turn it into a 1. To get a 1, we multiply by the reciprocals. So this will be 1/8 times this 8, which is in row 2, to yield a new row 2. After we get our 1 in our pivot position, we work on turning the other numbers in that column into zeros. To get zeros, we multiply by the opposite numbers. So this is an 8. I'm going to be multiplying by negative 8. This is a 56. I'm going to be multiplying by a negative 56. I'm going to be multiplying my pivot row, which is row 2, and then adding the rows I want to change. So I'm trying to change row 1, and I'm trying to change row 3 to yield new row 1s and new row 3. Okay, I could do all of this by hand, but we have a program that we're allowed to use for our calculator. So get out your calculator and do second x negative 1 and edit matrix A. This is a 3 by 7 matrix. And after you get the size in there, go ahead and start entering your coefficients. So I'm going to do that starting with my 8, 7, 2, 1, 0, 0, and 13. 8, 14, 6, 0, negative 1, 0, and 10. And 56, 56, 43, 0, 0, 1, and 0. So now that I have these entered into my matrix, I'm going to hit second mode and go to programs, and I'm looking for the program called row ops. So scroll down wherever it may be in your calculator. We're looking for one called row ops. Hit enter and enter again. And it should bring up that matrix you just typed in. Take a second, take a look, make sure that your numbers are in there correctly before we get started. Okay? Mine looks all right. So in my calculator, it'll do all of these row operations for me. The first one, where we're trying to get a 1, is in your calculator under to multiply. So what we're doing is choosing the option in our calculator to multiply. That's option number 2, and hit enter. And we are going to be multiplying row 2 by 1/8. So 1 divided by 8. So notice that there's now a 1 in your pivot position. In your calculator, turning numbers into zeros is taken care of by the to pivot option. And we'll be pivoting around row 2, column 1. That's where our pivot position is. So in your calculator, we're going to be pivoting around row 2, column 1. So now in my matrix, I have this 0, 1, 0, negative 7, 7/4, and negative 42, negative 4, 3/4, and 1, 1, 0, 0, 1, negative 1/8, 7, 0, 0, 1, and 3, 5/4, and negative 70. So something here should catch your eye, and that is the fact that your z value is negative 70. That's okay, because we're doing the opposite of minimizing. We need this negative sign to be down here. All that does is help our matrix keep reducing every time. But when we answer what the actual solution is, it's just a regular old 70. So this negative 70 down here in the corner is fine. Take a look at your matrix. Do we have any more variables that are negative in basic? And we do not. So right now, y1 is equal to 5/4. Y2 is equal to 0. Y3 is equal to 0. S1 is equal to 3. S2 is equal to 0. And Z is equal to 70. So no more negative basic variables. Now we go back into the regular simplex method mode. Do we have any negative indicators? So this number is not considered a negative indicator, just down here. Yes, we do still have a negative indicator. So this becomes our pivot column. We're looking for the smallest quotient, and remembering that our quotient can't be negative, and we can't use 0 as our pivot position. Since these two are both negative, our only choice to pivot around is the 7/4. So start by turning your pivot position into a 1. So we are going to multiply row 2 by 4 over 7. So multiplying by the reciprocal in row 2. Next, we will get these two numbers to turn into zeros. So to get those numbers to turn into zeros, we use opposite signs. So we will use a positive 7 to turn this into a 0, and a positive 42 to turn this into a 0. Multiplied with our pivot row, plus the rows we're changing, will yield a new row 1 and a new row 3. So bring back your calculator. In your calculator, when we're turning something into a 1, this is called to multiply. And we are going to be multiplying row 2 by 4 divided by 7. So in your calculator, hit enter, and 2 to multiply row 2 by 4 over 7. So notice there's now a 1 in your pivot position. Next, we're going to turn both of those numbers into zeros, and we do that in our calculator with the to pivot function. And where is our pivot position now? It is in row 2, column 2. So in your calculator, choose option number 3 to pivot around row 2, column 2. Right? So now our matrix looks like okay. So we no longer have any more negative indicators. That means we have reached the optimal solution. So I'm going to label my points up here, my variables, so we can see what they were. So that means y1 has a value of 0, y2 has a value of 5/7, y3 has a value of 0, s1 has a value of 8, S2 has a value of 0, and Z has a value of 40. So I have a minimum of 40 when y1 equals 0, y2 equals 5/7, y3 equals 0, s1 equals 8, and s2 equals 0.